Welcome back, Mr. Drew here. We are going to be continuing our talk about atoms. So thank you so much for coming. Question of the day: what can we do with atoms? Well, here is a company that got very good at not only seeing but moving atoms. Each atom that you guys see there on the screen was one collection of a molecule, or basically a small group of atoms that they were able to move around. So as you see here, each of these dots or silver circles is a small group of atoms, and they figured out how to actually move them around, take a picture, and make the video. If you want to see more about that, check on the video links. We'll put up more of that movie, and more interestingly, how did they make that movie? So there will be a video link about how they made the movie. Today, let's look at our atom unit test coming next Thursday and Friday, which is the 22nd of October. And don't forget, your element project is due October 21st, which is the Wednesday. Element project due Wednesday. Let's review a little bit, because last time we talked about how we're going to review for this test, but we want to definitely give you guys the complete answers and review for this. So one thing I noticed when we were going over the review packet, protons and neutrons making up most of the mass of an atom is probably one of the trickier things you'll be thinking about for this test. Each particle in the nucleus is one mass unit. So protons have a weight of one mass unit, neutrons as well have one mass unit. Reading the periodic table is pretty straightforward. The atomic numbers giving you protons as well as electrons. Our symbol, name, and mass are also given. Remember, we're rounding the mass so that we can get a nice even number of neutrons, because we need to subtract the atomic mass minus the atomic number to get those neutrons. Let's look at our atom review chart and make sure we filled in all of the different categories. When we look at a proton, it's a positive particle in the nucleus with a mass of one atomic mass unit. Neutrons are neutral, also in the nucleus, one mass unit. Electrons are negative to balance the positive protons, found in orbitals outside the nucleus, and they have basically no mass. If I were to label the parts of an atom, then I would want to definitely label my nucleus here. That's the central core with the positive protons, the neutral neutrons, and it has all of the mass. My electrons are these dots here. And remember, they don't actually live in nice rings like this. They're moving around at the speed of light, jumping from atom to atom. Protons and neutrons are the two circles in the nucleus. And if I wanted to know which was which, one easy way to do this is to count up my electrons. Believe it or not, the electrons are equal to the number of protons. I notice that I have 6 electrons, so I will need 6 protons. Well, it turns out that both the red and the white circles both are 6. So in this case, it doesn't matter which one you label. But if I add another round circle here, then suddenly it does matter. And then in that case, the protons would have to be the white circles. 6 protons, 6 electrons. The neutrons would be the red, And we might have an isotope here of carbon, an isotope being an atom that has an extra neutron in the nucleus. Let's take a look at our periodic table review, because we want to make sure we're able to calculate, using our periodic table, the number, mass, protons, neutrons, and electrons. Let's look at oxygen, whose symbol is O. Atomic number given on the periodic table is 8. The mass was given as a number that could be rounded to 16. I know my protons is the same as the atomic number, therefore 8. I also know that my positives and negatives are balanced. That's why I have 8 electrons. The neutrons are given, but to calculate neutrons, it's just a matter of subtracting the mass, taking out the protons, and you're left with the remaining neutrons in the nucleus. Lithium, I'm looking in my periodic table to see the capital L, small I. 3 protons, 3 electrons. The mass is given as a rounded number to 7. 7 minus 3, in other words, the mass of the nucleus, taking away the protons, leaves us with 4 neutrons. Hydrogen's an interesting case. It's the only element that has no neutrons. We got that with a mass of 1, take away the 1 proton, there's nothing left. There are no neutrons in our hydrogen atom. Nitrogen, number 7 on the periodic table, mass of 14. I could calculate that. Protons plus neutrons equals 14. Continue. Make sure you're able to use your periodic table, filling in the rest of the numbers in the same way that we've done the others. There are some review items for you guys. There is the periodic table and atoms in the folder of the week. So Quizlet's a great way to study. It gives you flashcards and a practice quiz. There's a Kahoot. There's also now a Quizzes there as well. So that now you've watched this video and hopefully you've gone through the answers to your review packet, it's time to study. You should know the things in your notes, especially starting with your review packet and working backwards. Make sure you're able to memorize the key important parts of the atom. Make sure that you are comfortable with your element project. I messaged the remote learners the element you'll be working on. Look in the folder so that you can go ahead and complete all the parts. Let's take a look. Here's Schoology again. Let's take a look and make sure we can find all of the things we need to do for our element project. Notice the interactive periodic table and these other resources which give you information about your element. If I click on the interactive periodic table, I can find all the elements of the periodic table. If I'm doing number 24 chromium, you can click on chromium to see a picture of what it looks like as a metal. You can find all the measurable physical properties, other properties, and interesting information. What is this used for? Is it found as a compound with other elements? Where can it be found? When was it discovered? Find the most interesting things you can and tell us what it is and why it is. To do citations, simply follow the directions here on this website. And when you're ready to complete your project, open this Word document. I'm going to open it in the desktop app. For a neater version that I can actually write and draw on. Nothing to do in the template other than here, in the rubric I should say, other than make sure you've got the accurate information. Name, symbol, mass, number, and all of these other properties. The diagram, you can easily get that from the internet. I gave you a website to source that. An element card, works cited, your work time, and a bonus if you'd like to build an actual 3D model. Here's a rough draft to put your ideas, and here's where you're going to actually put your information. Is this a solid, a liquid, a gas? Is my element a metal, non-metal, or metalloid? List your properties. such as examples here. List interesting facts, such as ideas to get you started here. Works cited, and then in your template for our periodic table, you'll be deleting the word atomic number and putting a number, deleting the word symbol and putting its symbol and name and mass. Then we can print out this square and hang it on our wall to make a brand new periodic table. So guys, hopefully that gave you something to do, to work on, and to get ready for. And thanks so much again for joining us. We'll see you next time here, Studying Atom.